Non-functional requirements are here to tell us not what the system does, but how it does it. And they're really tough. I don't want to pull punches there. Some of them are really obvious and they seem really good to go, but they're not always apparent, particularly if you aren't fully enmeshed in a real world project. It's easy to come up with vague notions of ones. They're not super useful. I mean, every system wants to be efficient. Every system wants to be cheap. Every system wants to be fast. So the question is, what do you really need the system to do? And that's part of the capturing of non-requirements is you want to first focus on your functionality, what the system does and who's doing it. But then we want to capture, okay, well, how fast does it really need to be? Or what are other ideas and features that need to be out there in the system? You can get really wrapped around the axle of non-functional requirements. I've seen systems waste a ton of time trying to meet specific performance requirements that they never really need to meet or aren't necessarily going to ever be a problem. But at the same time, there are systems where it's absolutely key. I mean, if you build a application that resides on an embedded system, for instance, a satellite, you don't want to use 100% of the memory on the first deliverable of that because then you can never upgrade your software, right? How many times have you had on your cell phone like, hey, I can't update this app because there's no memory left, and so you have to delete an app in order to update an app? That's craziness, but it certainly happens. So that's what non-functional requirements are for. The functional requirements tell us what the system does. Okay, so what are the screens? What are the behaviors? What are the needs? The non-functional says, well, what does it look like in the space it does it? How much memory does it take? How long should it take? What different colors should it use, or what different features? Should it have both audio and video and text, because we want to accommodate for people with different reading abilities or sighted and hearing difficulties, things like that. So there are some standard categories that's often out there. So performance, usage, quality, extensibility, expansion. These are different things out there. We're going to give some examples of them as we go. The categories don't mean anything. They're more of a way to jog your memory. I think the assignment might even ask specific categories. Well, not every system has every one of these. Not every system has a speed requirement or a size requirement. I mean, if I have a big server application, hey, I have memory's cheap. It's huge. Just go build the thing. I don't care if it takes up 5 gig. I don't care if it takes up 100 gig. I've got servers with terabytes out there. Go, run, go. So not everything has that, but there are some aspects that are really important, like security in particular. Every system should be secure. Well, what's specifically unique about your system that makes it potentially a security risk? What's the stuff that absolutely must be secured? So let's talk about these. Whether you're doing use cases or whether you're doing shalls, you have to you capture non-functional separately. They're basically measurements of the system, and the use cases really can't tell us that at this step the system shall do the. We really typically will capture this as shall requirements in some sort of third-party way. Occasionally there are non-functionals for specific use cases. At this step, when the user hits buy, the system shall give them a response within 5 seconds, even if the credit card isn't finished. Okay, that's a very specific performance requirement, but generally non-functionals are something that's a little bit more spread out. The system shall not, the system shall refresh all web pages within 3 seconds. That's a tough requirement, and it's really tough to measure. But you probably should have some caveats on that. So let me just dive into this example for the second. So what do I mean by that? Shall respond within 3 seconds. Well, if the tester is sitting in the same room as the server, then 3 seconds might be ridiculously easy to meet. Where if the tester's on the other side of the country and it's going through many proxy servers, it could be really, really hard to meet that same requirement. Because it might be a test box that they're running on. It might not be as strong as the eventual server. So it's easier to measure something in from the point of request to the point of return on the server. Every web request shall take less than 0.8 seconds. And then you don't have to measure internet lag time inside of there. If somebody has a slow dial-up connection, they're not going to hit your 3 second on every page, no matter what you do, no matter how fast your server is, because the internet itself on a dial-up probably takes 10 seconds to refresh any page. So you want to be very specific on the context and what you mean inside of that. And that's one of the things we talk about and how we capture these things. So again, more specific examples. Error messages and other representations will use text indicators other than just color to allow for ease of use for the colorblind. So often, you'll have error messages show up in red. And that'll be the only thing that's different about them. If people are colorblind, they can't see them. So put an asterisk next to them. Put a little image next to them. Something that indicates that it's an error message. You can just say error : It doesn't matter what it is here in the requirement. It's a usability requirement that conforms with the Americans with Disabilities Act. So that's one example of a very specific requirement. It's something that can be copied and pasted to everybody. Often some requirement like this is you have some sort of usability guide, and what you put in your system is our system shall conform to the usability guide of the company. And then we don't have to capture all these little ones. We captured them already. Web page formatting shall allow the user's use of screen reader technology. Okay, so what that means is when I order my HTML, it's got to be done in such a way where if somebody's using a screen reader, it makes sense. That accommodates for people with very low vision that can't see web pages and want to use readers instead. Customer service shall have the ability to see the user screens as the user does. This is a very interesting requirement, but the point of it is sometimes the user sees something on their screen and the customer service has a completely different set of technology that they can see stuff. And so the user keeps saying, it says this on my screen. The customer's like, customer service is, I can't see that. So I've seen systems that have a functional requirement of sorts, but it's really non-functional. But it's a functional need. It's not something the users does. But the customer service can log in to, not as the user explicitly, but as an analog to the user. It's the customer service logged in, but they see the screens, the same technology, the same code that's running, as if the user was running it, just through different credentials. And then they can see, oh yeah, I can see on your screen it looks like this. It looks like there's a technical glitch. Or, oh no, you're looking at the wrong spot. Go to the top left corner, not the bottom right corner. So that's a very specific functional, non-functional requirement inside of there. It's a feature of the system, but not a business feature. It's a support feature of the system. So often it's chunked into non-functional requirements. Credit card data shall be stored according to KISP standards. So it's something externally. It's anytime credit card data is touched, we want to meet this standard. Again, we can go through these specifically. You can look at them in more detail if you have any questions on them. There, we saw the iPhone and the Android thing. That's non-functional right there. The web page loading time we talked about in some detail there. Again, that's not a great requirement. We talked about that already. It's a little bit more specific would be good on what's exactly desired. What do you actually need? It's better than saying shall be fast. At least we now know what fast means. But how do we accommodate for different situations? We could have everything pass, and then it's still slow when you get to production because we weren't accounting for firewall lag times or something like that. And then the last one I talked about is embedded systems. Shall not exceed more than 75% of the processing capacity, and on average 50%. So again, we want the hardware to be usable on the phone. If I had the new version of the iPhone and the operating system took up 75% of the processor all the time, well, you can't run interesting apps on top of that because there's no room for that. There's nothing to be able to run. So you want it to be much lower. Normally this used to be a bigger deal because the hardware had a hard time keeping up with the software. We've now got to the point with Moore's Law that the hardware is typically way faster than what I can do with software on most applications. So it's not as big of a deal, but this used to be a huge deal out there. All right, so the ramifications of this is non-functional requirements normally impact the whole design. They normally have a whole different branch of testing that comes off of them because the testing isn't specifically testing one feature. It's got to make sure that thing is throughout everything. So non-functional requirements often have to be taken into account in testing in that on each one of my test cases, I must also test for this thing. As I test all the screens, make sure that all the error messages have more than just a difference in color. On all of the screens, make sure the timing is this thing. So you want to write them very carefully. You want to mean exactly what you say. You want to, as in every requirement, consider how will you test this. Don't just write something down like, hey, the system shall be great. Okay, well, what does it mean by great? You have to define that. If you can't define that now, what you're essentially doing is you're letting somebody else define that later, and they might have a different vision for what great is. And so you want to make them clearly measurable. You want to know exactly how do we determine this quality and that it comes up to meet the needs of the stakeholders. All right, so that's what we're looking at this week, functional and non-functional requirements. That's how we're going to capture that. Best of luck within that. This is just a place we talk about it. You really should write some down and seek feedback, whether from peers or coming into a chat and asking about them. That's where you're going to learn more about this, is you're probably not going to write perfect requirements the first time out. If you did, then you're either doing a great job learning or you didn't need this class to begin with. But this is something that does take some understanding, some practice, some refinement. And so expect to get some feedback. Expect to have some tweaks inside of there. Expect to make some changes to this class. It's okay. They won't be hopefully massive, but they're probably going to be adding some details. And think about, be reflective inside of this. Why didn't I think of that to start with? Not to say that you are dumb and shouldn't have. I'm saying from a process standpoint, is this something you just didn't realize that was out there? Or did you just not realize, hey, that's the type of details that are important? This is where learning comes in, as we talked about. Learning how to learn is really important in IT, because one of the things we're constantly doing is learning new things, whether it's technology or the new systems that we're working on. And so being reflective in why didn't I know that is important, because maybe you can figure that out quicker next time. Maybe there's a gap in the way you view the world that can be filled in through this. So why didn't I get more specific on what fast meant? Well, that's because I've been working in this industry for a long time, and I just thought that fast always meant 2 milliseconds because that's what fast always means for us. I just need to write down 2 milliseconds next time. Or, I had no idea what fast meant because I was brand new to computers because I didn't know what that means. So maybe I should go look up what fast means, or, write something down. 10 seconds. Well, that's not very fast. But again, that's the type of thing I want to encourage you to do. Within requirements, we need to be really thinking about not only what we wrote down, but how we knew that information or why we captured it the way we did, because that's going to help us become better designers and better requirements capturers.